Hello, Miss Roll here. Today we are going to do a little bit of notes on speed and velocity. So we'll go ahead and get started. So first of all, what is speed? So speed is a measure of how fast an object is moving, how fast it's moving. Speed is only a number and a unit. So you could say 5 meters per second, right? Number and unit. Speed cannot be negative. It's always going to be a positive number. And to calculate speed, speed is distance divided by the change in time. And remember our units, speed is in meters per second, or m/s. Distance is in meters, just m, and time is in seconds. So that unit actually shows us how we calculate speed, right? m/s, m divided by s, meters divided by seconds. And that helps us understand speed. Next thing is velocity. So velocity is the rate at which an object changes its position. Okay? So if we go back for a second, speed was the measure of how fast an object is moving. And velocity is the rate at which an object changes its position. So very similar, but it's a little bit more specific and more scientific. Velocity has a number, a unit, and a direction. So remember, speed was just number and unit, but now we're adding direction. And because it has direction, velocity can be positive or negative because it's directional. So that kind of indicates which direction it's going, right? If we have a negative number, it might indicate somebody's going backwards. So positive velocity has a positive slope, and we'll talk about what that looks like on graphs in a minute, and is going forwards, right? Increasing the distance. Whereas a negative velocity has a negative slope and is going backwards or decreasing the distance. Okay, so let's look at some similarities and differences. I'm going to go ahead and zoom in a little bit here. All right, so for speed, velocity, and acceleration. All right, there we go. So for speed and velocity, how are they similar and how are they different? So let's take a second to think about speed. Well, if we remember, speed can only be positive. Speed is always going to be positive, whereas velocity can be positive or negative, right? So velocity is both. And if we think about what we have to show for speed, remember we have the number and unit, right? So like 5 meters per second. And for velocity, we have number, unit, and direction, right? So we add direction into there. That's really important for velocity. And then some of the things that might be similar between the two. Remember, both are measurements. All right, it goes on to kind of 2 lines there, measurements. And remember, they are both calculated distance divided by time. You can write that whole thing out. I just wrote d divided by t. And of course, their basic unit is meters per second. Remember, the only difference is with velocity, we have to add some kind of direction. Okay, so there's a lot of things that are very similar between speed and velocity. So now we're going to take a look at what these look like on graphs. Okay, so speed graphs are going to have time on our x-axis and distance on our y, right? So we got distance divided by time, right? That gives us our speed. So what does the slope represent? It represents the speed or velocity, right? So if we have the direction information, it can be a velocity, but this is going to give us our speed. And remember from math class, slope, right? It's kind of like the steepness of that line, right? Steepness of the line, that's giving us our speed. So how do you know which object is moving the fastest? So again, we're looking at the same graph. We got time on the x, distance on the y. And looking at our graph here, which object is going the fastest? You might have intuitively said that yellow is going the fastest. Okay? And the question then is why? Well, it's going the fastest because it has the steepest slope, right? So if we have our, different slopes, it's got the steepest one. It's going up the most, okay? That tells us that it's going to be the fastest. If we look at numbers here too, right? We see in 10 seconds, it went a whole 60 meters in only 10 seconds, right? Whereas this red line in 20 seconds only went maybe 10 meters, right? So if you look at those numbers too, it shows us it's going the fastest. So I kind of just answered this, but which object's going the slowest? Yeah, it's red, and it has the least steep slope. I'm a tongue twister. Least steep slope. Can't spell either. That's okay. Okay, but again, that's kind of a slower one. If you look at the numbers, it's only going like 20, no, not even 20, like 10 meters, right? 10 meters in 20 seconds, right? So not very far. And then now here's a great question. Looking at our graph, are these objects going away or coming towards? Well, if you think about it, our distance is positive numbers, right? And when it's positive, we can say that they're going away. They're going away from us, right? The distance is getting greater away from us, okay? Let's take a look at another graph here. How do you determine the positive or negative velocity from a slope? Okay, so our previous graph only had positive things. So if we look at our graph here, which object is going the fastest? Again, it's yellow. Went most distance in the smallest time, or it's the steepest slope. Which object is going the slowest? Now, you hopefully was able to answer red, right? Because it covered least distance in longest time. And, right, it's got the least steep slope, right? It's not very high. It's not going up. So that's telling us that it is going the slowest, okay? Again, are the objects going away or coming towards? This is a bit of a tricky one because yellow and blue are going away, right? Because their numbers, their distance is getting higher in the positive. But if we look at our red line here, red started at 10 and is going down to 0. So that means it's actually coming towards us, right? Because that number is getting smaller. All right. Now, how do we tell positive versus negative velocity? Right? So we're looking at whether the line is kind of going up as we go to the right or if it's going down. So we see yellow and blue have a positive velocity, right? Basically because they are going away from us. The numbers are getting bigger as time gets bigger. As the time gets bigger. And then which objects have a negative velocity? It's red because it is coming towards us. Okay? Or another way to say that, right, is that distance is getting smaller, the distance numbers, as time is getting bigger. Okay, so if that line's going up, it's going to be a positive, and if it's going down, it's going to be a negative. All right, last slide here. How do you identify speed and velocity from a graph? Okay, so let's think again. What does the slope represent? It represents the speed, right? Overall slope is how fast it's going. So now looking at this example, what is happening between 10 and 20 seconds? So remember, time is down here on our x-axis. So I'm going to find 10 and 20. So looking at it, it's sitting at 10 meters for both 10 and 20 seconds. So what do you think is happening? They're not moving, right? If the distance isn't changing over a period of time, or we got that flat line, it's got no slope, means it's got no speed or velocity, so it's not moving. Okay, next one, are the speeds at 0 to 10 and 50 to 90 seconds the same or different? Okay, well, let's look at 0 to 10. 0 to 10 seconds here, I've got this line, it's going up, and that means it's going, 10 meters in 10 seconds. Okay, and then I'm looking for 50 to 90. Okay, 50 to 90. So it looks like we've got, 10 meters being covered in 10 seconds there, 10 seconds there, 10 seconds there, 10 seconds there. Okay, so these slopes are going different directions, but if I look right between, let's say, 50 to 60 seconds, it went from 40 to 30, 10 meters. So in 10 seconds, it went 10 meters, which is exactly the same as our 0 to 10 seconds. So that means actually they're going a different direction, but the speeds are the same, okay? Because they're covering same distance in the same amount of time. And now are the velocities at 0 to 10 and 50 to 90 seconds the same or different? Well, this one's even easier because I don't have to double check that they're kind of the same amount of distance in the same amount of time. I just have to know they're going in opposite directions. And if they're opposite directions, that means their velocity cannot be the same. So they have different velocities, right? Different directions. One's positive, one's negative, not the same velocity. All right, that is it for your notes. If you have any questions, please make sure that you ask. And I hope that you have a wonderful day.